Hey guys, I'm gonna do one more of the homework questions from lesson 3. So, this is number 5 on lesson 3. It says a balloon is rising vertically above a level straight road at a constant rate of 1 feet per second. So, what's happening is this balloon is rising up, it's going up at a rate of 1 feet per second. So again, whenever we'll be dealing with the right triangle questions, I'm always going to try use x for my horizontal distance and y for my vertical. Here it does say x and y and z for my hypotenuse. Okay, this is how I'm going to do. And another thing you need to remember is if your height or your distance or your any kind of length is not changing, like a ladder or a string that is not changing, it's just a string. There have been multiple examples like that. Your derivative or your rate of change for it will be 0 because it's neither increasing or decreasing, so there's no rate of change happening. So the please make sure we understand those things. And whenever we're dealing with the right triangles, we are using Pythagorean theorem and then we are differentiating implicitly. Okay, so we already read this. It's rising at a rate, so this would be dy dt, right? 1 feet per second. Just when the balloon is 65 feet above the ground, so when it's 65 feet above the ground, a bicycle moving at a constant rate of 17 feet per second passes under it. So the bicycle was underneath here. Okay, so the bicycle was here when it was at 65 feet. But now the bicycle moved what? And the bicycle is moving at, so this would be dx dt, and the length is increasing, right? So it would be 17 feet per second, right? And 3 seconds later. So how far did he travel 3 seconds later? Either you can use the formula distance as rate times time, or if you were thinking of 17 times 3, which is that rate time, so 51 feet. He traveled approximately 51 feet, right? Similarly, when he was right here, your balloon was at 65 feet. And this is what? Your dy dt is 1 feet per second. So 3 seconds later, how much would it rise? Plus 3. So total of 68. So when he is at 51 feet, he traveled far to 51 feet. You are at, the balloon is at a height of 68 feet from the ground. Does that make sense? Right? So now it's saying how fast is the distance between the bicycle and the balloon. So I want to find this distance, which would be what? It actually says s. I'm going to use ds dt or dz dt, whatever you want to say. Let's say ds dt. Right? I don't know this. So how fast is the distance changing? But I don't know this. But do I know s? I don't know that too, but I do know the two sides of a right triangle, which is 68 and 51, and I can find my s. So I'm going to use my Pythagorean theorem, which is a square plus b square equals c square. Here my a is 51 square plus b is 68 square, right? And c square. So you can put that in the calculator. Your hypotenuse is always across from 90. We should all know that. And it would be 85. Okay, so now you want to find the rate of change, right? So, or how fast is the distance between the two changing, the balloon and the bicycle. So I'm going to take my Pythagorean theorem, x squared plus y squared equals, I'm going to say s squared here. It's s squared. I'm going to take the derivative, so it'll be 2x dx dt with respect to time, right? 2y dy dt, and that's my 2s ds dt. The 2's, if I factor out the 2 here and 2's, these will cancel out, right? I hope you all understand. And all now we're doing is substituting in. So x is what? X was 51 times 17 plus 68 times 1 equals 85 times ds dt. So if I solve all this, I get ds dt to be, I'm going to add this and divide by 85. That's what you're doing. And that would be 11 feet per second. So that's what your answer. So I hope you understand these questions. If you have any questions, again, I have extra help from 2:15 till 3. Please log in and ask me questions. You will have your